Okay, now we're gonna start thinking about something that gives many of us, students and adults, a big nightmare. That is the study of logarithm. And of course, I would like to introduce to you the logarithmic function. Before we can go far ahead about getting the derivative and differentiation of logarithmic function. And now, let me just say a couple of words about logarithms before we start. A logarithm is going to be the thing that untangle the exponential function. Remember we saw back on the inverse function that untangling the action or decode the action of another function. Well, it turns out that the exponential function is the function that is one-to-one or has an inverse. And so there's some way to decode the exponential in order to get back just that x. And now, that decoding thing that I'm saying is just the logarithm. Simply, I'm just saying that there is a big connection between log and exponents. So let us take a look. Here is the primary principle of logarithm. The logarithm of a number is the exponent to which the base must be raised to produce that number. And I would like you to understand this magical mantra, right? That log is equals to exponent. Always remember this chant. The thing that you always keep in mind that log is an exponent. This is a clue for you. That's how simply to remember it is. That's the mantra. And we're going to differentiate between the common logs and the natural logs. So in the common logs, we have log of x is equals to log base 10 of x. And in the natural logs, we have natural logs of x is equals to log base e of x. And common logarithm is any logarithm with base of 10. So if you encounter a logarithm that has an invisible base or there's no base in it indicated, it means that the base that you're going to use is 10. It is simply 10, always 10. Remember that. And natural logarithms are different than common logarithms. While the base of the common logarithm is 10, the base of a natural logarithm is the special number e. Although this looks like a variable, it represents a fixed irrational number approximately equal to 2.7181828 and so on. Like pi, it continues without a repeating pattern. E is sometimes called the Euler's number or Napier's constant. I'm sorry, I pronounced it wrong. It should be Euler's number or Napier's constant. And the letter E was chosen to honor the mathematician named Leonhard Euler. So again, this is not as this word is not being pronounced as Euler. It should be Euler. Okay. And now let's move forward for defining how does logarithm look like. The logarithm again is a number that is an exponent to which the base must be raised to produce that number. Say we have y is equals to log base b of x. Okay, so as you may take a look, this y is our exponent and this variable b will be our base. And when we raise y with the use of our b, we will get this value of x. This is exactly the same thing as this statement. B raised to y is equals to x. So remember, you can take this to be the definition of log. Okay, so in order for you to understand more what is this, or how does it work, let us take a look at the example here. We have here log base 2 of 8 is equals to what number, or what is the value? Okay, again, this question mark is the one that we're looking for. This is the exponent. Okay, remember the mantra. Log is an exponent. Log is equals to exponent. So this question mark, we are looking for what for the value of it, and this serves as the exponent. And our base will be 2. So think of any number, or give me any number that when you raise to this question mark or this exponent, you will get this value of 8. Okay. Again, this is exact same thing as this statement. 2 raised to the unknown exponent, 2 raised to the unknown value is equals to 8. So you already know that 2 cubed is equals to 8. So it means that our question mark, or the unknown value here, is 3. Right? So our answer will be log base 2 of 8 is equals to 3. Right? Let us take a look to another example. I have here log base 2 of 1/4 is equals to what value? Again, remember the mantra. This question mark represents the exponent. So our mantra is log is an exponent. Logarithm is an exponent. So we're just going to solve and find out what is the exponent that we can use when we have this 2 as our base. That will give us the value of 1/4, right? So this is identical to 2 raised to the unknown exponent is equals to 1/4, right? So as you can see, we have this equal value of 1/4. So it made us, or give us a clue that our exponent will be negative, right? And then it means that our unknown value of exponent is -2. So let us do a checking. 2 raised to -2 is equals to 1/2 squared, right? Because any number you raise to a negative exponent, when you got that value, you need to, or to make it positive, to make positive the negative, you transfer, or you switch it into fraction, okay? And then you will have that positive exponent already. So we have 1/2 squared. And you already know that 2 squared is equals to 4. So it will give us the value of 1/4. That means that our answer is correct. Log base 2 of 1/4 is equals to -2. Alright? And let me just give you a tricky one. I have your log base 2 of -3 is equals to what exponent? Okay, because remember the mantra, logarithm or log is an exponent. So we're looking for this question mark, and we're just going to think of any number that when you take 2 to that power will give you the -3 as the value, or as the result. Are you working pretty hard? Okay, so let me give you this identical statement again. 2 raised to any exponent is equals to -3. So again, give me a number that when I take 2 to that power will give me -3. Okay, I know you're trying hard to guess it. And the answer will be impossible. So there will be no answer. That's right, because there's no such thing thing to raise to any power can give a negative value. Okay, any number you raise it to an exponent should give you a positive value. Okay, it should be always positive, because there's no way, or there's no such thing to raise to any power can give you a negative number. Okay, so never ever take logs of negatives. So it means that we don't have any answer for this. Alright, so that will be all for some introduction of our logarithmic function. And again, remember the little mantra: a log is an exponent. So thank you so much. God bless you all.